Our next recording here is going to talk about our second section in our stress and health chapter, and we're going to start talking about our different reactions to stress. Now, for our different types of reactions or ways that we can respond to stress, I actually want to break these down into three broad categories. So earlier on, talking about sort of internal versus external physiological responses and things like cognitive evaluations and stuff like that, we're going to kind of add a little bit of a level to that here. So we had already been discussing our potential stressors, which is our event in the environment. So I've been using the example of having an upcoming exam. So that exam is an event. And we can think of it as a more objective event because it's a thing that's going to happen. It itself is simply an event that has certain parameters. Whereas once we start looking at our appraisals, this is when we have a more internal and subjective process where we decide maybe what that stressor is going to require from us. That also includes our evaluations from one of the earlier models, talking about things like what resources do I have available to meet the demands that that particular stressor is going to ask of me. So that appraisal, we stress that it's very subjective because it involves our own interpretations of the situation and of my available resources, and then doing an evaluation of all of that. And then with that evaluation, we have some type of response. So here's the three types I want to talk about: emotional responses, which we'll do very briefly, then physiological responses, which will be the rest of this particular video, and then we'll move on into behavioral responses and other topics beyond that. So starting off, emotional responses, like I said, are going to be fairly quick here to get through. Of course, when it comes to emotions, emotions are messy. So emotional responses are going to also themselves be messy. And so we describe this as a complicated and changing relationship between stress and emotion, where the two can end up influencing one another. Being stressed can make you emotional, and being in a certain emotional state can actually change your appraisal of stressful situations and can make your reaction to a potential stressor very different than if you were in a different mental and emotional state to begin with. So oftentimes we're going to see that when people are faced with stressors, they might be apprehensive or fearful or anxious. But we can also see things like frustration and anger, or we could get into something a little bit more, say, giving up, getting into dejection and sadness and grief. So there's a whole range of different types of responses here related to our emotions. And again, it's a complicated interaction where no one type of stressor is going to always and consistently produce a particular emotional response. This is going to be very variable. It'll depend on the individual, but also that individual's current state when facing that stressor to begin with. So there's a bunch of really cool research in this area, but one neat one is done by Lazarus back in the early 2000s, where they found that specific cognitive reactions, some of our appraisals, ended up leading us to have more specific emotion patterns. So individuals who had more of a cognitive internal sort of self-blame focused framework, they ended up experiencing more guilt than others. And similarly, if people were sort of feeling helpless, this helplessness led them to more of a sadness and a little bit less of an active feeling. And if we get into our previous discussion where helplessness and sort of lack of control were mentioned in terms of affecting how we appraise a situation, that kind of makes sense. If you feel like your own actions are not necessarily going to help or improve a situation, then you might have a more negative reaction to it. And we find fairly often that having negative emotions and having negative internal cognitive processes being the norm is actually associated with more negative health outcomes. Basically, being more pessimistic tends to correlate with worse health consequences. And we'll actually see that a little bit later on when looking at some of the mechanisms of experiencing sort of physiological effects of stress. But starting point here, And then I think I mentioned the concept of frustration, but it's worth bringing it up again. I gave it its own slide here. But frustration is when you feel upset or annoyed, especially if you have an inability to change or achieve something. So this is again that idea of powerlessness. And this could be, instead of, say, going the give up route and feeling sad, this might just be because I've tried everything and I can't make this work. I can't overcome this particular situation. And so we might lash out with frustration, which can be tied to aggression, depending on, again, the individual and the situation here. So in our cases, we can talk about frustration often being seen if we're in a situation where we fail to reach a goal or fail to overcome a problem. That's kind of a neat way we'll see this used fairly often. But as I've said, we're keeping to having emotions and emotional responses fairly quick here, and we're going to move into our physiological responses next. Now, when we're talking physiological responses, we're looking at our internal body states. So instead of our sort of emotional and cognitive reactions, now we're just getting into what's the body doing? How are our systems changing? And so when we look at our stress responses, and we'll talk about our fight or flight response for another time this semester, this keeps coming up, which should tell you it's fairly important. This response is going to help protect us from harm and try and restore us to a state of balance. I've stressed before this concept of homeostasis, of our bodies being in balance, and stress being a state of imbalance, where we're encountering something that's sort of pushing us outside of our homeostatic norms. So we're going to be pushed beyond where we would like to be when our body is happy and at rest. And that tension that's created is usually going to drive us to act. And from that evolutionary point of view, it should drive us to act in ways that help facilitate survival. So we would like to be able to, say, fight off a threat or run away from a threat. And so we would hope that these responses are something that will help us beneficially face a situation. We will, of course, see that sometimes these responses are maladaptive, especially in more modern environments where the types of environments that we grew up in with our sort of evolutionary history, this was generations and generations and generations ago. Evolution is a very slow process. So we're talking in the realm of thousands and thousands of years for change to happen. So our current environment is very different from the nature that evolution would have been happening in. And so some of our stress responses are no longer super beneficial in today's modern environment. So just keep that in mind in the background. But when we talk about homeostasis, that's just our state of balance that can become upset by our stressors, and then our stress response can help us try and return to our balance. We return to our homeostatic point, and then we're sort of back in our balance state. So with our physiological responses, they're usually going to be fairly system-wide, coordinated responses, and they're going to involve, say, freeing up energy to help us deal with a stressor, things that are going to help us maybe avoid injury, reduce risk of infection if we're in a sort of a physical situation like a fight. All of those things are meant to be beneficial, and again, from that evolutionary point of view. So I keep mentioning fight or flight, and our standard fight or flight response is our emotional and physiological reaction to an emergency that increases our readiness for action. So we encounter a threatening situation and our autonomic nervous system is going to ramp up. We're going to have an increase in mobilized energy and we're going to be ready to fight off a potential threat. Though, while we typically just talk about our fight or flight response, there is also something called the freeze response. And this is what happens when we basically become immobilized when we face a perceived stressor. So rather than trying to fight back or to run away and escape a stressful situation, an individual might freeze in place, almost like playing dead when you think of possums. So they're going to freeze when a predator approaches and hopefully end up being sort of ignored in that situation. And this is something that does happen in quite a few species. Whether it's a sort of innate biological component of this, like with our possums, or sometimes it's a learned behavior, especially if you're stuck in situations where fighting or running away tends to make the situation worse. A freeze response can become something you learn is safer than fighting or running. So yeah, there are technically 3 Fs that we can include in this sort of autonomic nervous system response, but we typically only focus on fight or flight. I just like acknowledging that freeze is another viable option. Now, if we're going to be getting into these physiological reactions, a big chunk of this gets into neurobiological components. Basically, we're going to look at activity within our central nervous system. This is going to include things like neurotransmitters that are going to affect activity in the brain, but this can also include things like hormones that are going to circulate throughout the body and start recruiting systems on a larger scale. So this diagram here is just giving us a little bit of a visual reference point where we can talk about our hippocampus. These are all some of our what we call subcortical structures, at least these mid ones are, and those are going to be sort of in the deep portions of the brain. So this is the hippocampus, which is involved in memory formation, but also memory retrieval. So it's going to start recruiting information from, say, past experiences. It's going to help us learn from new experiences so that we can adjust our behavior in the future. So that's tied to memory and learning. Our amygdala keeps coming up repeatedly as something that helps us respond emotionally to different situations. So it helps us identify things that might be dangerous, and it's going to start recruiting all of the systems involved in our fight or flight response. So this is going to ramp up that central nervous system. The autonomic nervous system will sort of activate, and that's going to then trigger us to start reacting to the situation. We also have our thalamus here, and this one is important because the thalamus is our routing station. All of our incoming sensory information, with the small exception of our sense of smell, doesn't go through the thalamus, but everything else, our visual information, auditory information, all of it runs through the thalamus as it comes up our spinal cord. So once it hits the thalamus, that is then going to split information off, where say we have incoming visual information from our eyes. It's going to go back to the spinal cord, up to the thalamus, and then the signal gets split. Some of that information, the visual information, goes back here to the occipital lobe, which is our primary visual cortex. So we get to evaluate visual information with a more intentional eye. So this would be a more active process. We then have some of that information actually go forward here to the amygdala, because our amygdala gets early signals to make decisions about potential threats. So it's going to get visual information in a raw form to decide if we need to recruit our central nervous system for a fight or flight response. Same thing with our auditory information. It comes up to the thalamus, some of it gets sent to the primary auditory cortex, and some gets sent to the amygdala to make a quick decision as to whether we're being threatened or not. So that's a really important component here. And then we have our prefrontal cortex, which is just talking about our frontal lobe. This outer cortex, sort of the whole surface of the brain, is a lot of our different areas, different lobes. We are not getting too much into that, but the frontal lobe is what's tied to a lot of decision making, evaluation, sort of making the best choice with all the information we have for us now. So we can think about this as more higher order processing, where we can take, say, some of the amygdala's signals that have already gone out, recruiting that emotional response, but we also want to consider that emotion plus maybe the deeper processing we got from the visual cortex over here, where this part of the brain has actually looked at the situation. And while maybe the amygdala recruited the fight or flight response because we saw something that might have been a bear, then our visual cortex here looked at it closely and said, oh, it's actually just a dog, so we don't need to be afraid. So that identifying it as a dog gets sent forward, and the prefrontal cortex makes that decision that we don't actually need to be panicking, so we can tell the amygdala to stand down. So that prefrontal cortex is more, let's look at stuff that's been processed a little bit, let's start making decisions, let's start evaluating. Whereas the amygdala is going to be a lot more of a immediate gut response, trying to be quick because it's evolutionarily beneficial to be ready for a threat, even if you have some false alarms. And then, of course, I like talking over our visuals. I like having the diagram to talk over, but there's also the quick summary here, talking about the amygdala with our early stress responses and the fact that it's going to sort of coordinate with other areas of the brain. That'll be much focused on momentarily. The hippocampus for learning and memory, learning new things as we encounter them, but also remembering prior experiences, and then that prefrontal cortex for more higher order processing and specifically decision making. Very, very important processes. For this next section, we're getting into the actual sort of biological systems. We are going to be using a very simplified version of our sort of fight or flight system here. We're going to be looking at the autonomic nervous system as a whole, and then the two opposing sides of it, which is our sympathetic nervous system and then our parasympathetic nervous system, which we'll do in more detail momentarily. But this diagram here is one of my favorites to show what's involved in starting a fight or flight response. So first off, let's talk about the different divisions of our nervous system. Our autonomic nervous system is going to be the one that runs automatically in the background. The other portion of our nervous system would be the somatic nervous system, which is going to be more conscious components. But this autonomic system is all about that instinctive ramping up when we're facing a threat. And specifically, the sympathetic nervous system is going to be that activation, that fight or flight response. So when the amygdala identifies some potentially threatening stimuli, the sympathetic nervous system is what's going to activate, and it's going to start releasing a bunch of our stress hormones through a couple of different pathways over here. So we're specifically going to end up seeing norepinephrine and epinephrine, but we'll also get to see cortisol and its precursors as well. So again, momentarily more detail on that. But of course, if this is sort of ramping up that fight or flight response, we also need a coordinating system to ramp it back down again. This is where the parasympathetic nervous system comes in. So sympathetic nervous system is we ramp up under situations of stress. Parasympathetic is going to ramp us back down again to return to our homeostatic balance point. So when we were saying that we have maybe the amygdala has thought something was a threat, and then conscious evaluation with our prefrontal cortex tells us that it's actually not threatening, we're not in danger, then the parasympathetic system would kick on to bring us back into balance. So these work in opposing directions, one to ramp up, the other to ramp down for the most part. So what is this specific pathway? This is something called our HPA axis, or the hypothalamic pituitary adrenal axis. Fortunately, it's named that because it makes sense. We go from the hypothalamus, which is a component, it's another one of those subcortical structures. So you can see it labeled over here. And actually, if we go back to our diagram here, our hypothalamus is, I believe, this area here. It's somewhere in this, and I didn't label it, which is unfortunate. But since locations don't really matter, all we care about is the fact that it's in this same grouping with these other subcortical structures, and that's all I need. But the hypothalamus is very centrally located, and it's going to help us monitor the rest of our systems and keep us in balance. So it monitors not only the signals coming in from the brain, our electrical signals there, it also keeps track of different chemicals and levels within our bloodstream. So it has a very special job looking at both our bloodstream and our nervous system signals. So it gets a mix of both hormone signals that are sort of system-wide, but also our electrical signals that are a little bit more directed. We then also have the pituitary gland, which is going to be forward and a little bit below our hypothalamus. And the pituitary gland is responsible for secreting a whole bunch of different hormones. For us, we care about the pituitary gland secreting this ACTH, which is going to be adrenocorticotropic hormone. There we go. There's a reason why we use just the symbols, the ACTH, but that's the full set of words if you want. So that's what the pituitary gland does. It's going to be sending signals to a bunch of other glands throughout the system. And then, of course, we're going to have our adrenal glands as the third component here. And our adrenal glands are going to be responsible for sending out our stress hormones. So let's look at this actual process in order and go through the stages here. So our amygdala is actually going to come before the hypothalamus because the amygdala is what decides if we are activating our fight or flight response. So the amygdala kicks on, going to send a message electrically to the hypothalamus, and the hypothalamus is going to then send a signal to our pituitary gland. So that signal is corticotropin releasing hormone. And this one is not one that I'm super excited about or it's not super important to me is what I'm trying to say. I don't so much care about this one. I just care that the hypothalamus has sent a signal to the pituitary gland. So that corticotropin releasing hormone actually triggers the release of the adrenocorticotropic hormone. So the name actually makes sense because it's what it's doing. It's causing the release of this. And then that signal hits the pituitary gland. We get our ACTH. So that's this process here. And then the ACTH triggers our adrenal glands to release cortisol. And cortisol is going to be one of our long-term stress hormones. So that's going to produce physical effects throughout the body. Now, we're going to talk about these physical effects momentarily, but first, I want to acknowledge that there is a second pathway here. And interestingly, this pathway kind of skips over a couple of these steps. So here, orange is showing us that we have the stimulation of our SNS. That SNS is our sympathetic nervous system right here. And that sympathetic nervous system is going to send signals more directly to our adrenal gland so that we can have a quick release of two other hormones. Here we have epinephrine and norepinephrine. These are additional stress hormones. So all three, cortisol, epinephrine, and norepinephrine, are all going to serve to activate systems throughout the body in preparation for fight or flight. So one of them is going to get sort of a little bit of a slower pathway here where we're relying on this hormone to release this hormone to then trigger the release of this hormone. And unlike electrical signals, where our nerves can send signals fairly directly with electricity, so that moves really quickly, when we have hormones, this is a slower process because we are releasing chemicals and the chemicals are going to float around throughout the body until they reach an area that they have an effect. So this process is a little bit slower, but also more long-lasting, and it's going to affect the entire system as a whole as those hormones spread into the bloodstream. That doesn't mean that this pathway doesn't affect the whole body, because once we've triggered the adrenal glands to release epinephrine and norepinephrine, those are going to travel throughout the system as well. So both sides are going to give us a fight or flight response. They're going to ramp up our system to prepare for that stressor, but one is just going to be triggered more directly by that our sympathetic nervous system. Goodness gracious. Whereas the other is going to take a more roundabout route with hormones. But all of these lead to that activation that's going to produce some physical effects within our body that prepare us for a potentially threatening scenario. So things like your pupils dilate, they're going to open so that we let more light in so that you can see better. If you're facing a threat, being able to see it well and not miss details in your environment is important. Our heart rate's going to increase. Our rate of breathing is going to increase. We have more energy mobilized. But we also have here a reduction of systems that are not super useful. So things like our digestive system, being able to eat food and digest it is not very important in the moment when you are fighting for your life against, say, a bear. So these systems turn off to actually save energy that we can then use for other things. So because of the resources being prioritized, we're going to have blood moving very quickly, which can lead to our skin flushing. And as that heart rate increases and our breathing rate increases, we're circulating more oxygen and blood throughout the body to spread all that energy that we've mobilized. So this process is getting us prepared to be able to fight. This is also why if, say, you're in a situation like maybe you're not comfortable doing public speaking, you might find yourself breathing really quickly, and you might find that your throat's really dry, and maybe your voice is shaking a little bit with tension. That can all be traced back to our bodies treating it as a threat, but public speaking is not something that's necessarily a physical threat. That's where that whole maladaptive stress response discussion from earlier can come back in. Nowadays, our stress responses aren't always going to be super helpful because we'll see things like, say, public speaking or taking an exam as stressors, and we have a full body response that can sometimes kick in, which is not usually the desired outcome that we're looking for in these situations. Now, from this, we've talked about sort of ramping up these systems and ramping back down these systems depending on the threat and the situation. And that idea of these two opposing systems that help us keep in balance actually ties really nicely to our concept of feedback loops. And feedback loops are basically situations where the output from one system can influence the output of another system. So we can actually have positive or negative feedback systems or feedback loops. Now, I suppose I should explain what positive and negative feedback loops are before we move on from here, because you might not have encountered these before. But with our positive feedback loops, these are fairly rare within our biological systems. And that's because with a positive feedback loop, we're saying that as more of a signal is produced, we're going to receive another signal that says keep producing more. So if we're releasing a hormone, as those hormone levels rise, we're going to try and release more and more and more of that particular hormone. Obviously, this is not overly beneficial in most cases because we don't want an ever increasing amount of a particular substance. Instead, we'd usually like to have some kind of balanced level of substance. So negative feedback loops are usually going to be a lot more common. And within our HPA axis, we have some of these negative feedback loops where we're going to have sort of monitoring our signals, especially, like I said before, where our hypothalamus is going to be monitoring both neural signals and levels of things in our bloodstream. The hypothalamus is involved in helping us control the levels of different hormones that have been released. So, as too much of a hormone starts building up in the bloodstream, the hypothalamus is going to tell us to slow the release of that hormone. We'll have sort of an upper limit, and as we have too much buildup, we'll reduce the production and release of that hormone to stay within sort of acceptable levels. So this means that we're not going to have a spiraling out of control amount of any of our hormones. Instead, we're going to be able to sort of reset and return to normal levels as necessary. Our autonomic nervous system also works with something called reciprocal inhibition. So if we think of what these terms mean, so inhibition is going to be limiting the activity of something, and reciprocal means that they're going to affect each other. So all this means is that our sympathetic nervous system and our parasympathetic nervous system are going to both activate, but in opposite directions. So as one is active, the other can compensate in the opposite direction, maintaining balance. So typically, the sympathetic nervous system is going to turn on, it's our activator, and as it's pushing us out of our homeostatic balance, then the parasympathetic nervous system is going to work in opposition, and it can regulate or inhibit that activation of the sympathetic nervous system. So they both affect each other, they work in opposite directions, and we're able to regulate the activity of that autonomic nervous system with these two opposing forces. So lots and lots of different ways that we could regulate the systems. And I'm sure you can tell from just this very brief description that there are many, many different details behind the scenes beyond just the level that we talk about here. So we're keeping it very surface level and skipping a lot of the details. But if you are curious, you can take classes where you go into our nervous system in a lot more detail and talk a lot more about all of these processes. So yes, this is a very, very shortened version of it, and that is totally fine for our purposes. All right. Our next chunk of topics here are about our general adaptation syndrome. And this is more work done by Hans Selye, which we had talked before about as that sort of eustress and distress proponent. Wanted to talk about the importance of stress and how it can actually be beneficial. So he proposed this general adaptation syndrome as a way of explaining different stages of stress responses. And we break it down into 3 phases, the first being our alarm stage, then we have our resistance stage, and then we end with exhaustion stage. So this is the diagram here, and we're looking at, this is resistance to stress, where this midline is going to be where we're sitting when we encounter stress. Sort of this is our baseline. When we first face a stressor, that's going to cause a stress response where at first, encountering something that's dangerous or threatening in some way, shape, or form is actually going to lead to this initial downturn of our resistance to stress. This is taking resources. We're worrying about this briefly, and our bodies have to kick in to help us start adapting to this situation. Then we're going to start seeing sort of our shift to our sympathetic nervous system. So our fight or flight response is going to start kicking in, which is specialized to help us face stressful scenarios. So our second stage, getting into the resistance stage, this is when we start seeing our epinephrine and norepinephrine and cortisol from our 2 different pathways here. So this is, we start seeing our hormones being released by those adrenal glands, and we're getting sort of that increased arousal, which again is just an internal state. We have heightened levels of energy because we are ready to face this stress. And so we have this increased resistance to stress because our bodies are working to help us face this stressor. So our coping skills are enhanced. And then in our final stage, the exhaustion phase, we're just acknowledging that we only have a set number of resources available to us within our bodies. And while, yes, we've ramped up our fight or flight response and we're prepared to handle the stressor in this period of time, eventually we're going to use up our resources. And our resistance to stress is going to decrease, actually to the point that we end up being more susceptible to stress after we have used up all of our resources. And as we've used up those resources, we're kind of left in a deficit where our bodies are not able to resist stress. We're also then going to be susceptible to things like infection and aging and damage to different systems within our bodies because we've overused our resources. Now, coming into these slides here, I actually had to make a couple of quick changes to the text because I ended up squishing together some of the stuff from the first phase and the second phase and caught it as soon as I started trying to talk through it. So I've made an adjustment. I will update the slides later when I post the complete version of the slides. But here, when we're talking about our alarm phase, we're having that activation of the sympathetic nervous system. And this is sort of leading to that initial preparation. We're getting ready to send signals to our adrenal glands, and the adrenal glands releasing all of our different stress hormones is going to be an indicator of our second phase. So here we're saying that we're sending those early signals off to the adrenal glands so that we can then recruit resources throughout the body. So if I go back here, that would be here where we said we've activated our sympathetic nervous system as part of phase 1. We also have those early signals sending our different types of hormones to then trigger the adrenal glands to release hormones. So the 2 different systems are going to be encouraging the adrenal glands to release all 3 of these stress hormones. So that leads us into our resistance phase. When those stress hormones are set loose throughout the body, they're going to release blood sugar. So that's when we're mobilizing energy for the rest of the body. We also start seeing some adjustments to the immune system. And while we've said here it's suppression of the immune system, it's a little bit more complicated than that. There are certain aspects of the immune system that can be threatened, but we also see increases in the areas that would say help us prepare to respond to injury. So this would be things like we're going to focus on physical damage that maybe is causing bleeding. So we're going to focus on different things that can help us with clotting, so heal over wounds so that we stop bleeding. And then later we can see some of that immune functionality return. Though as time goes on and as our resources are sort of used up, we're going to have more and more issues with our immune functioning. But we'll come back to the immune system momentarily. Of course, with all of these different hormones being released and all sorts of different resources being recruited, this also includes things like our heart rate is still fast, our breathing is still deep, we have heightened blood pressure, and all of these things. Obviously, we can't maintain that heightened state indefinitely. So, as time goes on, the parasympathetic system is going to try and restore homeostasis. We're going to try and get back to our balance point. But if a stressor is still present in the environment, then we're still getting a signal that says that the sympathetic nervous system needs to be active. So the two are going to be working in opposition, where the parasympathetic system is trying to bring us back into balance, but the sympathetic nervous system is not going to shut down until the threat has left. Unless, of course, we run out of resources, which is where the third stage comes in. So our resources get dangerously depleted. And like I said, as our resources are used up, our immune functioning gets worse and worse and worse. So this can lead to vulnerability to disease. It also produces a lot of strain on our system, and using up those resources and working extra hard can end up leading to long-term damage to, say, our cardiovascular system. So our heart and lungs are going to have been put through a lot of strain by being in a heightened stress response for prolonged periods, and it just leads to a lot of wear and tear. And with enough of these long-term stress responses hitting this exhaustion phase multiple times, say due to chronic stressors, can lead to these systems wearing down fairly extensively over time. Now, I did promise that we'd talk more about the immune system. And this is important because as we're going through these stress responses, we have a whole bunch of hormones that are released. And as I've said, hormones are traveling throughout the body via the bloodstream. And this means that they're not going to one single targeted location, they end up affecting the whole system. So, as these different types of hormones are released, they're going to have some pretty widespread impacts. So, first that we're going to talk about are glucocorticoids. Oh my goodness. One of those days for pronunciation. Glucocorticoids. There we are. These are types of hormones that are going to go throughout the system, but especially are going to have a pretty strong effect on the brain. And as they're impacting those areas, they're reducing our ability to have immune responses. And this, again, is because we're focusing on things like being able to respond to physical injury and have our blood clot. So we have maybe less functioning in terms of fighting off invading, say, bacteria, viruses, things like that. Our ability to fight things off lessens. This is actually one of the reasons why, whenever you've had a prolonged period of stress and you finally get to relax and you kind of hit that stage of, I'm absolutely exhausted and I've been pushing so hard, usually, say, post exams, you almost always end up getting sick as well. And that's because having all of those resources used and then used up can lead us unable to fight off things like, say, a cold or a flu that have entered our system. So having that stress response reduces that immune functioning overall. Now, I do keep talking about our ability to fight off, or sorry, to allow our blood to clot. And this ties to our inflammatory response. So this is still part of the immune system, but this system is specifically looking at sort of injury, where we might have something like body tissues being damaged. So while these glucocorticoids are going to reduce some of our functioning, we do see some others that are going to end up boosting some aspects of it. This is another one of those areas. I keep talking about the fact that we're only doing like a Coles Notes surface level discussion. depending on which types of chemicals we're looking at, they're going to end up sort of boosting and restricting the same systems. So yeah, this is why these, instead of the glucocorticoids, these are going to be cytokines. And these are going to help us regulate inflammation, and these are going to help with things like clotting. So some aspects, like the ones related to this inflammatory response, can help boost some of those immune functioning, specifically targeted for things like physical injuries like cuts and bruises, and help promote healing in those areas. But we're not great at fighting off, say, bacteria, viruses, things like that. And as time goes on, even this inflammatory response is going to get less and less effective as those resources work or are used up. So yeah, so if we encounter these stressors, we see more of these cytokines in our systems that are going to help with that inflammation and help fight off or heal from different fight type injuries. And then this inflammation itself, while on the surface it seems like a good idea to be able to say, yes, we are now capable of sort of healing after cuts and bruises, again, prolonged exposure to an inflammatory response is actually damaging. So having more of our inflammatory proteins, these cytokines, it actually puts wear and tear on other systems within the body. So you can kind of think of it like our bodies eventually end up sort of oversensitive, looking for potential damage, and they can actually end up killing off what would have been perfectly healthy cells, maybe being a little bit nervous that they could be damaged. So having too many of these anti-inflammatory proteins floating around, they can end up causing cell death and damage on larger scales. And again, the longer this goes on, the more these are having a long-term effect, and more systems are affected, things like that. And one of the reasons that they think that this has such a strong effect and how chronic inflammation might relate to our susceptibility to disease as we encounter more and more stressors actually ties to the concept of biological aging. And so biological aging is just our tendency for reduced cellular performance as we age. This ties to the idea that as we get older, our cells are only able to make copies of what was already present. So every copy that we make, every time one cell turns into two and two into four, we're working with a finite resource. And so specifically, when we talk about our chromosomes and the ends of our chromosomes, we have caps at the ends called telomeres. So I have a visual for us here, but these telomeres are going to be this section of DNA that doesn't have any important information in it. So we can think of them as non-coding DNA, where these telomeres are going to get smaller and smaller as time goes on because we're not able to add to our chromosomes. Well, not really. If you get into the genetic side of things, there's like ways to sort of protect them a little bit, but there is always a limit. So as we make new copies of our chromosomes to make doubles of our cells, we're going to find that we lose just a little bit off the ends each time. And if we think about it, over the course of our lives, we have thousands and thousands of divisions across our cells, and we're going to find that those protective caps wear off at the end. So you can think of this almost like if you have a chair and you have one of those little plastic caps under your chair to keep your chair from having the metal tear into your carpet. At the beginning, they're nice and round and functional and all that, but the more you move your chair, the more those plastic caps wear off, and eventually the metal is still going to come into contact with your carpet. The thicker the plastic, the longer it takes for that to wear away, but eventually you are still going to wear everything down. So the same basic idea here, that as we get older, those protective caps get smaller and smaller and smaller until eventually we're going to have our coding DNA, the stuff that's important, that actually gives us useful instructions, that starts getting worn away too. And as we start losing some of our instructions, then we're going to have issues where these cells can't function any longer. And so as these cells have reductions in their functionality, we're going to say they become unstable and they're more likely to die. Or they can be killed off by some of our sort of protective other measures, things like those cytokines. They're going to identify cells that need to be terminated because they're no longer capable of functioning. So, why does stress end up correlating with these sort of problems with our telomeres? If we think about it, coming back to the fact that as we're more and more stressed and as we have sort of more exposure to those inflammatory proteins, well, we're going to end up having more and more cells killed off and need to be replaced. So as we have more unnecessary cell death from that system being overactive, we're going to have to make more copies. And more copies means more loss of those protective telomeres. And over time, as we do that over and over and over again, these cells are going to have less and less telomere left until eventually we're going to start damaging our DNA, usually a lot faster than we would have if we hadn't had so many unnecessary replications, unnecessary copies made of our cells. So in these cases, this has led to a situation where, yeah, we're having damage in these areas that leads to the telomeres being used up a lot sooner. And specifically, this damage is going to be especially concentrated in some of the systems that are most strongly affected by our stress responses. So our immune system is one by having all of these different chemicals floating around and having sort of attempts at spiking our immune functioning to prepare for damage and then using up our resources too aggressively. We also have our cardiovascular system. Our heart and lungs are put through their paces when we're in a fight or flight response. Heart beats faster, lungs work harder, blood pressure is higher, and that wear and tear is going to lead to more damage and more unnecessary replacement of cells with high levels of our inflammatory protein. And within our nervous system, this is sort of neurodegenerative issues, basically degeneration, damage of, and loss of our neurons. And our neurons are just cells within our nervous system. So it makes sense that as these cells are encountering these aversive situations, they are going to be damaged. And the issue with our neurons and our nervous system is that neurons are very unlikely to be able to be replaced. So unlike something like replacing some of the cells in our heart wall, where we just get new muscle cells and everything's fine, with our neurons, as they die, they are very rarely replaced. So that wear and tear is going to be a little bit more direct there because as those cells are lost, they are no longer replaced. And that just means that we have fewer connections left within that system. But in all of these cases, these are things that are very susceptible, areas of the body very susceptible to the effects of stress and those long-term, very widespread bits of damage that can accompany it. Now, when it comes to our behavioral responses, this kind of like our emotional responses is going to be a pretty quick and brief section to discuss, but it does serve as a really nice bookend to come in on the other side of our sort of biological and neurological explanations, because those get a little bit more deep and more sort of remember a bunch of systems and remember a bunch of hormones than maybe we would like. So let's do behavioral responses to wrap up this section. First thing we can talk about coping, and coping stress is when we're actually making efforts to either master or reduce or even just tolerate the demands that are created by stress. Now, the term coping is something that is kind of interesting to discuss because the societal use of the word coping is usually implying that we have some kind of healthful behavior, something that's beneficial. So we cope by doing something to reduce our experience of stress. But in psychology, when we talk about coping, it could either be healthful, it could either be beneficial, or it could be maladaptive. Because oftentimes, when we attempt to use what could be coping strategies, they actually end up being more harmful than beneficial. So we'll find things that maybe don't end up being as useful as they could be. And a lot of that might tie back to things like some of our cognitive appraisals of maybe the resources we have available versus not available. So yeah, our coping strategies can be hit or miss depending. So we just want to keep that in mind. If we want to focus on sort of beneficial coping mechanisms, that's what we would call constructive coping. So these are going to be fairly healthful efforts that help us deal with stressful events in a much more beneficial manner. These don't guarantee success. These types of approaches are not always going to be effective, but they just tend to be more likely to help than others. And again, this is often leaning into framing a stressor in a way that's more beneficial than harmful. So, a lot of our coping mechanisms, whether they're good or bad, are going to be talking about how we approach a situation, how we think about it, how we evaluate our own abilities in order to handle that scenario. And as you can probably imagine, if we're trying to handle scenarios better, we lean towards wanting to treat it as more of a challenge than a threat, using some of the terms from an earlier model. So, what are some ways that we can approach these problems in a more constructive way? The first is to come at them directly. So, you want to ask yourself questions like, what is the task? What is it exactly that I need to do? By having that sort of objective evaluation of the situation, you are then sort of giving yourself a more realistic expectation of what you're going to face. We want to constantly be looking at the situation, also evaluating our progress towards handling it. Because if we continue thinking that we have this huge thing up ahead of us, but we're actually making progress and the task is getting smaller and easier, framing it as still being a big problem can actually make us feel discouraged, which we don't want. We'd also want to be open minded about, well, maybe my strategy's not working, and perhaps I need to make some changes to what I'm doing. Making those adaptations as time goes on can be really beneficial too. So don't just commit to something and then blindly follow it. Continue updating your views and continue looking at your resources and the demands in an objective way. We, of course, want to have that realistic appraisal of the resources that we have available to us. So make sure that you're not underestimating your abilities. The interesting part here, though, is the fact that if you frame things very positively, if you're very optimistic, if you're sort of boosting your own opinion of yourself, it can be a little bit helpful to be optimistic and maybe a little bit sort of overconfident. But if you take it too far, it can actually be a detriment. So if you hype yourself up too hard, you might think that the task is going to be really, really easy and then come at it unprepared. So realistic appraisals are actually going to be a lot better than being too optimistic. So we'd rather lean on the a little bit optimistic, but don't go overboard side of things. And then, of course, another skill that's really important is being able to take that step back, not just to evaluate the situation and the stressor itself and your progress in completing it or overcoming it. We also want to step back and look internally and start looking at things like our internal emotional responses, because those emotions can end up skewing our perspective. So if we're getting frustrated because something isn't working, we might frame things a lot more negatively and be more likely to start viewing it as a threat because of that internalized state. So we want to recognize that the emotions that we have can play a role, and maybe we can take steps to try and regulate. I know for myself, if I'm getting, say, really frustrated with a recording where something is not quite working and I'm not saying it quite right, sometimes I have to pause and go for a walk and come back. I've learned that it's not going to go any better if I try and fight through it. It's a lot better to take a break, take a step back, and come to it with a more level head. That's going to be a lot more beneficial. Now, if those are sort of the best case beneficial approaches that we should consider, some of our constructive approaches, what are some of the maybe less helpful things that we'll encounter? There's a whole bunch of terms that are going to be mentioned here very, very briefly, the first of which is something called learned helplessness. Now, this is something that I get to talk about a lot in terms of the learning literature, because learned helplessness is an interesting phenomenon where if an individual encounters a situation where their own actions are not able to prevent something bad from happening, they sort of end up giving up and they no longer try and make behavioral responses. This also applies to stress because if you encounter situations where bad things are happening, stressors are happening, and your actions aren't helping reduce it, oftentimes people will stop trying to alleviate that stress. So this leads to a lot of passive behavior. So after you've encountered lots of unavoidable aversive events, lots of high stress scenarios with bad outcomes, people tend to give up. So we can see things like resignation or acceptance. This also ties to things like that external locus of control, where people have learned that my actions don't matter, so I'm not going to bother trying. That's not necessarily a beneficial state to be in. And it can often end up tying to things like self blame because you are thinking, well, I've tried everything, but I'm not smart enough to find a way around this, or I can never overcome this type of stressor. And that negative framework can make you think more negatively and then frame things more negatively to see them as higher stress or higher threat level in the future. So it can end up causing these sort of chain reactions of progressively more negative thought patterns. So this can lead to things like, or things that we would call catastrophic thinking. So this would be like, I'm never going to find a solution. I'm never going to be able to overcome these tasks. Nothing is ever going to go right. Basically think worst case scenario. And again, oftenly critical of themselves for having gotten to this point where they are incapable of having a role to fix that stressor or to overcome a challenge. So yeah, we can sort of see how this ends up sort of being a problematic and maladaptive approach. Now, if you can turn some of this on its head, where instead of giving up and sort of stopping trying, maybe you take that step back and adjust your goal. So I wasn't able to overcome the stressor from this way. What about if I try something different? Or what if I try and only manage part of a stressful event and the rest can come later? So by maybe breaking things up, by looking at it from a different angle, you can overcome some of this, but that isn't always very common. And once you're in a situation where lots of aversive things keep happening and nothing you do can alleviate it, that sort of negative spiral can be very likely to occur. Other fairly maladaptive processes can lead to things like self-indulgence. So if you're in a very stressful situation, you might be a lot more likely to allow yourself to engage in things that maybe you shouldn't, specifically because it might help you feel better in the short run. So by having these high stress scenarios, our self-control tends to be weaker. So we're a lot more likely to act impulsively. So this could be things like, well, maybe I want to go out and grab snacks. I want munchy food while I'm dealing with this stressful situation. Or I'm going to go out and I'm going to go shopping because that makes me feel good. I've dealt with this high stress scenario, or I have to deal with this high stress scenario. Therefore, I deserve some kind of present or treat or something. So this can lead to changes in how we eat, the money we spend, the stuff we're buying, and can actually tie into addiction. So if you're in lots and lots of stressful scenarios, it does also correlate with higher rates of addiction. And again, I'm sure you can tell there's a lot more going on behind the scenes there, but Cole's Notes version, we're going through this quick. We can also see our defense mechanisms pop up again here. We mentioned those earlier talking about Freud, but with our defense mechanisms, we can have some pretty maladaptive frameworks. So we can talk about things like maybe repression, where we're not going to think about things. We can deflect, we can put blame onto others, things like that. So those defense mechanisms can pop back up again. And just as a refresher, they're going to be typically unconscious actions that help us mediate some of the sort of violent emotions that we are going to experience when encountering stressful situations. And rather than actually just accepting some of those negative emotions, we choose to try and, say, deflect them onto something else, bury them, avoid them, mediate them in some way, shape, or form. And that's where those defense mechanisms come in. And then into our last two sections, talking very, very briefly about burnout. Burnout is a current buzzword in media right now. This is something that isn't a new concept. It's been around and described for years and years, but it's become something that people are talking about a lot. So what is it? Burnout is going to be both physical and emotional exhaustion tied in with things like cynicism, so negative thought patterns, being overly critical, as well as a lowered sense of self-efficacy. Basically meaning that you are going to underestimate how much you can do. You're going to feel like you don't have an effect, that you can't do anything, that you can't change anything. You end up feeling powerless. And burnout is usually talked about in terms of chronic work-related stresses that exceed our ability to handle and cope with, that is going to end up with us feeling like we have no more resources left over. And as we get to that point, once we've hit burnout, that exhaustion and negative self-thinking and feeling like we can't accomplish anything, that's usually triggered by things like having too much work with too few resources, or if your work is not recognized, if you don't feel valued in your place of work, or again, that lack of control. What I do doesn't have any impact, and therefore I feel like it doesn't matter what I'm doing. All of those things are going to tie together. And for some of our consequences, higher rates of burnout link to increased rates of physical illness. And if people are going to be sick more, we're going to see that people miss their work or miss days of work more often. This also leads to people quitting jobs more often and being less committed to their job. And then, of course, we also see that they're getting less done in the same amount of time because of all of these things, having very little energy, feeling very critical about everything, and not feeling like doing stuff matters. It's definitely not going to have people motivated and excited to be doing work. So these are some interesting summaries of what burnout looks like, sort of our starting point. So what leads to it? What do we see as a result? And what are the consequences of those different components in action? A pretty neat summary here. And then the last topic is an acknowledgement of post-traumatic stress disorder, and more of a claim that we're going to talk about this much later on when we get into psychological disorders and treatment of disorders. But we do acknowledge that post-traumatic stress disorder, it has stress in the name. It is related to high stressor situations, and it also leads to the reoccurrence of stressful situations as things like flashbacks occur, where people end up reliving those original stressors. So this is a situation, PTSD is an enduring psychological disturbance after experiencing traumatic events or event. So this could be one or more depending on the situation. But this is going to come with a whole bunch of other side effects, things like distress, flashbacks, depression, anxiety, insomnia. This is a very complex disorder with multiple different aspects to it. So this is saying it is related to stress, but we're going to talk about it in chapter 15. I think that's chapter 15 when we get into psychological disorders. So it'll come up there. So you have that to look forward to, I suppose.